every move of the decimal to the left adds one exponent. In other words, the power of 10 increases by 1 every time you move the decimal to the left. Okay. All right. So that's how you write scientific notation for big numbers. However, what about small numbers? What about numbers less than 1? And what about like decimals? Okay. All right, so let's do this one, 0.01. That's like 1 cent. And 1 cent is 100th of a dollar. So how would you write that in scientific notation? Well, some of you probably know. Okay, it's going to end up being 10 to the minus 2, or 1 times 10 to the minus 2. Okay. Basically, you take the rule that we have up here and you do the opposite. Okay, because here what you're doing is you're taking the decimal, instead of moving it to the left, you're moving it to the right. Okay, so if you take the decimal and move it after the 1, it's -1, -2. So you have 1 times 10 to the -2. Okay. So 1 cent would be 10 to the minus $2, or 1 times 10 to the minus $2. Okay. A nickel, 0.05, well, that would be, move it over 1 place, 2 places, that would be 5 times 10 to the minus 2. So notice, it's not the number of zeros in this case. Even though we only have 1 non-zero digit, it's not the number of zeros because you have to move it over. Well, you don't have to, but most of the time what you do is you move it over after the first non-zero digit. Okay? So rule number 2 then is each move of the decimal to the right subtracts 1 exponent. So in other words, every time you move the decimal to the right, you reduce the power of 10 by 1. Okay. So let's try one here. 0.00341. Okay. So you can hit the pause button on your computer and try this on your own. 0.00341. All right. Well, let's see what we come up with. You take the decimal and you move it over 1, 2, 3 places, and you get 3.41 times 10 to the minus 3. Now, some of you who have tried this, hopefully, at home, maybe took the decimal place all the way to the end and said 341 times 10 to the minus 5. Okay? This is not incorrect. That's not wrong. It's the same exact number. These two numbers are exactly the same. Okay? This is the more standard way of writing it. Okay? This is the more standard way of writing it. But again, this is not incorrect. All 3 ways are the same number. Okay? It's just 3 different ways of writing the same number. Okay? So let me just write down then what standard form is. Standard form, the way we usually write scientific notation, and there are exceptions to this. Okay? So for example, if you want to write down 14.5 million, okay, that's not a standard form way of doing it either. That'd be 14.5 times 10 to the 6th. But sometimes you want in terms of billions or millions or whatever. But most of the time, we do it like this. Okay. In scientific notation, the decimal is usually usually placed just after the first non-zero digit from the left. Okay. So if you read the number left to right, the first non-zero digit in this case is 3. Okay. Here the first non-zero digit was 5. In our previous examples, you read it from left to right, and then you move the decimal to the left to just after the first non-zero digit. Okay. So that's what we would call standard form. So one more example. Let's say we have 0.00083. Okay. See if you could write that in standard form. Okay. Again, hit the pause button and try it on your own. All right. Well, you should have come out with 1, 2, 3, 4 places to the right. So that would be 8.3 times 10 to the minus 4. Okay, 8.3 times 10 to the minus 4. All right. So that's how you write really large numbers and really small numbers in terms of scientific notation.